Welcome to the derivative function. So the idea here is we have been able to find the derivative at a point. Right? So far, we have found the derivative at a point. But what if we did this for all points instead of just a specified x equals c? So what if we did this for all points in the domain? Instead of a specified x equals c. So the derivative function instead of using x equals c, we will just do this for any x. So we will have f prime of x is equal to the limit as h goes to 0 of f of x plus h instead of c plus h minus f of x all over h. Again, we're just keeping it in x instead of putting in the specified c. So we've been doing this all along, but now if we want to do the derivative function in general, we can find lots of derivatives all in one go and just plug in our c at the end. So let's go ahead and find the derivative function for f of x equals 3x minus 5. So we have f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. This is a fairly simple function without any squaring, so I'm just going to go ahead and plug everything straight into the formula. So we have the limit as h goes to 0 of 3 times in parentheses x plus h minus 5 minus, and in parentheses 3x minus 5 all over h. So it's extremely important that you remember that we are subtracting off the entire f of x, not just the first component. So put that f of x in parentheses. From here, this becomes the limit as h goes to 0 of 3x plus 3h minus 5. Then we have minus 3x plus 5 if we distribute that subtraction all over h. Now, if we do some combining like terms, our minus 5 and plus 5 will combine to give us 0. And then our plus 3x and minus 3x will combine to give us 0. And so all we are left with is we have the limit as h goes to 0 of 3h over h. This is a 0 over 0 scenario. It's already factored. We can go ahead and cancel out our h's, and we get this limit is equal to 3. Now, if we look back at the original problem, we were looking at f of x equals 3x minus 5, which we know that is a line, right? And that line has slope 3 everywhere. So it kind of makes sense that the derivative, which is just the slope at any given point, would also be 3. So note, this is just the slope of the line, y equals 3x minus 5, right? Which makes sense since the derivative is just the slope at that point. So if we take a line has constant slope, right? A line that's the same slope all the way through. So the derivative should just be precisely that slope everywhere. On the other hand, let's now go ahead and take a look at the function g of x equals 1 over x minus 2. So if we wish to find that derivative function, we know that g prime of x is equal to the limit as h goes to 0 of g of x plus h minus g of x all over h, which is the limit as h goes to 0 of 1 over x plus h minus 2 minus 1 over x minus 2 all over h. Now, if we wanted to simplify this a little, we need to make it so that numerator is all one fraction. And so if we give the numerator a common denominator, to give the numerator that common denominator, we have two options to do this. We can either multiply, just clear the denominators, or we can combine the fraction up top. So I'm going to do what is called clearing the denominators. And I'm going to multiply the top here by the least common denominator, which would be x plus h minus 2 times x minus 2. And if we do that to the top of our big fraction, we should also do it down below. So we have x plus h minus 2 times x minus 2. Now up top, in the first fraction, we would have so in the first fraction, the x plus h minus 2 and the x plus h minus 2 would cancel, and we would just be left with x minus 2. So in the first fraction, we are simply left with x minus 2. Then we are subtracting, going back to the original multiplication. We are now going to multiply 1 over x minus 2 times that least common denominator. So in this case, the x minus 2's will cancel, and we will just be left with the x plus h minus 2. And then down below, we will have h times x plus h minus 2 times x minus 2. So again, I'm going to go ahead and erase my canceling out because that was term by term canceling, and I reset every time we finished a term. If we go about simplifying this numerator, we have the limit as h goes to 0 of x minus 2 minus x minus h plus 2 all over h times x plus h minus 2 times x minus 2. Again, we have a minus 2 plus 2 scenario. Those cancel out, go to 0. we have a positive x minus x situation. Those cancel each other out and give us 0. And so up top, we are simply left with negative h. So this now becomes the limit as h goes to 0 of negative h over h times x plus h minus 2 times x minus 2. At this point, we can cancel out our h's. Up top, we're just left with a negative 1. And we can go ahead and plug in our h equals 0. And we wind up just with a negative 1 over x minus 2 will pop up both the term with the h and without, so it'll become x minus 2 squared. So we wind up getting that g prime of x is equal to negative 1 over x minus 2 squared. I just want to show you some alternate notations here. So an alternative notation you may also see this notation, d dx, and then with the original function. So the original was 1 over x minus 2. So this is d dx of 1 over x minus 2, means take the derivative of 1 over x minus 2. And you would get negative 1 over x minus 2 quantity squared out. So that's an alternative notation for saying that we're taking the derivative. So this is finding the derivative function.